In this lecture, we discuss about trajectory and orthogonal trajectory. Let us first take what is the history of trajectory and orthogonal trajectory. The concept of trajectory originates from classical mechanics and projectile motion studied as early as ancient Greece by Aristotle. It was more rigorously developed by Galileo Galilei in the 16th century, who showed that the trajectory of a projectile under uniform gravity is a parabola. Newton later generalized it using his law of motion and calculus, providing a scientific foundation. The idea of orthogonal trajectories emerged from differential geometry in the 18th and 19th centuries. Mathematicians like Euler, Lagrange, and Laplace explored a family of curves and their geometric relationship, leading to the formalization of orthogonal intersections in the curve families. So these are about the history of orthogonal trajectories. Now, what is the definition of trajectories and orthogonal trajectories? So what is the meaning of trajectory? A curve which cuts every member of a family of a curves according to some definite law is called a trajectory of the family. A curve which cuts every member of a family of the curve according to the some definite law is called a trajectory of the family. For example, suppose we have a horizontal line. So if there is a vertical lines, this is one vertical line, two vertical line, three vertical line, four vertical line, and so on. We can draw many vertical lines. Right, and now if we see that what is the angle between the intersection of the horizontal and vertical line, it is 90 degree, it is 90 degree, it is 90 degree. So we can say that this horizontal line is a trajectory of the vertical family of the vertical lines. So this is called trajectory. So a curve which cuts every member of a given family of curves according to some definite law is called a trajectory of the family. So now what is the orthogonal trajectory? A curve which cuts every member of a given family of curves at right angles is called orthogonal trajectory. For example, here this line, horizontal line, cuts each and every vertical line by right angle, means 90 degree. So this is called orthogonal trajectory. The next thing is the orthogonal family of curves. So two families of curves are said to be orthogonal if every member of either family cut each member of the other family at right angles. Let me tell you some example. Now this is the family of family of trajectories only, because this is not 90 degree, but this is the family of trajectories. There are two family, one is parabola and another is hyperbola, and another is family of circles. Now if I will tell you this is again an example of trajectories. Now this is the family of orthogonal trajectories. Just look here, these are the radius of the circles, and this radius of a circle, if we draw the tangent at any point, this tangent will be always perpendicular to the radius of the circle. So this is what? This is the family of orthogonal curves. Is also the one more example of trajectory. And now this is the again one example of orthogonal trajectory. So the orthogonal trajectory only, this is the one line. This line intersect the circle 1, circle 2, circle 3, circle 4, circle 5 by right angle. So this is what it is again called a orthogonal trajectory. What are the importance of orthogonal trajectories? So the first point is understanding the motion of objects or which is called trajectory is crucial in all branches of engineering. Orthogonal trajectories help in electrostatic, fluid flow, and structural stress analysis where fields intersect at right angles. Like that, suppose if we see our flooring of the any flat, so what we will do, we have seen like this. There is a tiles. This is the one tile. This is the another tile. This is the fourth tile. So now if you see that, what is the angle between these two tiles? It is nothing but 90 degrees. So this is again one example of orthogonal trajectories. Engineers use this concept in design, control systems, signal processing, and robotics. The next thing is the trajectory prediction is vital in aerospace engineering, automotive, and mechanical systems. So these are some very important, these are the things which are important in engineering. Now, what are the applications? So the first application is in projectile motion, which is used in ballistics and defense system. Second is the rocket and satellite launches for calculating flight paths. Space mission planning to planning orbits and re-entry paths. Robotic arm movements, tracing optimal path for end effectors. Vehicle dynamics, steering and path tracking in autonomous vehicle. It is also used in electrostatistics, where electric fields lines and equipotential lines are drawn. Fluid mechanics in streamlines and lines of constant pressure. Now it is also used in stress analysis in civil engineering. So stress lines and straight strain lines in materials. It also used in navigation system to find flight path versus isochrones or distant contours. And it also used in game physics for calculating interaction of paths with force field. So these are some applications of orthogonal trajectories. Thank you.